Hello students, welcome to UNIX programming. We will see the third module in that the fifth lecture. So today we will see regarding the process control. Here we are going to discuss about the introduction, process identifiers, fork, vfork, exit, wait, wait PID, wait 3, wait 4 function, race conditions, exec functions. First, we will see the process identifiers. Before that, we will see what do you mean by process. A program under execution is called as the process head. So each and every process is identified by using some unique ID number. So that unique ID number is called as the unique process ID, which is a non-negative integer. There are some special processes. Process ID 0 is there, which is a scheduler. Next is process ID 1, init process. Init process are never going to die. It's a normal user process run with the super user privileges. Then the third one is process ID 2, that is the page dimmer. Then next we will see some of the functions by using which you are going to access the different process IDs. So to make use of those functions, you have to include the two header files, unistandard and c/types. The first function is get PID. It will be used to access the process ID of the currently running process. Then get PPID means get the PID of the parent. Get UID. To access the user ID, you are going to use the get UID. Get EUID means get the effective user ID. Then get GID to get the group ID. Then get the effective uh, group ID. You are going to use the get EGID. Next is fork function. A new process is created by the kernel Unix kernel when an existing process are going to call the fork function. Means to create a new process you are going to make use of the fork functions. Okay, and this is the syntax for using the fork function. It is going to return the process ID and not going to take any arguments here. So just here already I have one functions or the process, okay, that is my parent. So in that I am going to call the fork there. So whenever I am going to call a fork function, another one process will be get created there. Okay, so newly created process, it will be called as the child, whereas the previous one it will be called as the parent there. Here, the new process which is created by fork is called as the child process, whereas the function fork function is called once, but it is going to return the twice there. The return value in the child will be 0. Then the return value in a parent is the process ID of the new child there. The child is a copy of the parent there. As we can see here, the child is the copy of a parent. Child gets a copy of the parent's text, data, heap and the stack. Means child can access the text, data, heap and the stack segments. Next is properties which are inherited by the child. Real user ID, group ID, effective user ID and effective group ID are the inherited. Supplementary group ID is also inherited. Process group ID, session ID, set user ID and set group ID. These all things will be inherited. Then even controlling terminal, currently working directory, root directory, file mode creation, mask. These all things will be inherited by the child there. Even resource limit, environment, attached shared memory segments, these all things will be inherited by the child whenever the parent is going to create a child. Next is the difference between the parent and child. The return value of the fork. Okay, the return value of the fork is, it is going to return the value as 0 if it is created successfully, else it is going to return the -1, else it is going to return the parent ID. So here it is going to return the two IDs. One is its ID and the parent's ID. Here the process ID and the parent process ID. The fork's process ID will be 0 and it is going to have the parent's process ID also. And the value of times u time, utility time, system time, current time and use time is 0 for the child. And the file logs which has been set by the parents are not inherited by the child. If you are going to set any mandatory or any file logs for the parent, those logs are not inherited by the child. Even the pending alarms are cleared for the child. A set of pending signals for the child is set to empty set. Then the function of the fork is, a process can duplicate itself so that the parent and child can each execute different section of the code. Whenever you are going to call the fork function, it is going to create a duplicate of your parent so that parent and the child process can execute parallelly or simultaneously. And there will be some situation that even the process can execute a different programs also. We'll see one example here. Just see int main, int id. I have created one integer. I'm just printing hello world. Then I am creating one a child. I'm called creating one child. What's here? Fork equal to id here. Id is equal to fork. So if it is created successfully, it is going to return the id of that child. If id is greater than 0 means what? Now you are in the parent. Okay, whatever the id is, then if it is greater than 0 means you are in parent. So printf, this is the parent section, so just you are displaying the get PID there, get the ID there. Else if ID is equal to 0 means now you are in the child process. So fork has been created, get the process ID, currently running process ID. With that you are going to get the get PID. What I have told in the previous slides, if fork it is going to return the two values. One is the its PID and the parent's PID. So those two numbers values will be displayed here. If it is not created, then what you are going to see that fork creation will be failed. Then vfork is there. It is going to create a new process, but it is going to block the parent. Okay. So here this is the syntax for using the fork. Just see the example here. Int main, printf before vfork and printf after vfork. In the normal fork, what happened? Parent and child both are going to execute parallelly. But in case of vfork, what happens? Till the child will be get executed, the parent will be get blocked there. We'll see the difference between fork and vfork. First one is the address space. Both the child and parent process will have a different address space. Okay, where vfork, both the child and parent process, they are going to share the same address space. Then modification in the address space. Any modification done by the child in its address space is not visible to the parent process as both will have a separate copies. Next, any modification which is done by the child process is visible to both parent and the child as both will have the same copies there. Copy on write. This is going to use the copy on write, where vfork does not going to use the copy on write. Execution summary. Both parent and child are going to execute the simultaneously. Parent process will be suspended until child execution is completed. Outcome of usage. Behavior is predictable, behavior is not predictable. Then next is exit functions. Already we have seen that exit functions, the exit will be done in two forms, normal termination and the abnormal termination. So in the normal termination, the first one will be the return from the main. Just if you are going to call any return function from the main, so normally that process will be get terminated. Then second form will be by calling the exit method. Okay, it is going to include the calling exit handlers, and another one form will be calling underscore exit. Okay, and even we have seen the difference that where exit it is going to perform the cleanup operation and then return back to the kernel, whereas the underscore exit it will be immediately uh, return to the kernel there. Then the abnormal termination is whenever you are going to get the SIG abort signal, that is signal abort, the abnormal termination will be done. When the process receives some certain signals, abnormal termination will be there. Okay, the same thing will be applied to your fork also. Then exit status, it is used to notify the parent how a child will be terminated. Whatever the exit status is there, that will be used by the parent to check how the child is terminated. When a parent is terminated before the child is inherited by its init process. If the child is terminates before the parent, then the information about this is obtained by parent when it is going to execute wait or wait PID functions. The information it is consist of the process ID, the termination status, and the amount of CPU time which is taken by the process there. A process that has terminated but whose parent has not yet waited for it. Such process has been called as the zombie processes. When a process is inherited by the init terminates, it does not become the zombie there. Init executes one of the wait function to fetch the terminated status there. Next is wait and wait PID functions. A call to wait, it is going to block the calling process until one of its child process exits or signal is they receive. Whenever wait function is called, okay, that process will be get blocked till one of its child process will be get exits or the signal will be received from that child process. After child process terminates, parent will continue its execution after wait system call instructions. Child process may terminate due to any of these reasons. It calls exit, it returns from the main, it receives a signal from the operating system or the other processes whose default action is to terminate. The process that calls wait or wait PID can block itself block itself. Okay, so till that child can exit, then return immediately with the termination status of the child or return immediately with an error. Okay, so this is the syntax for wait PID and the wait functions. Okay, wait PID, wait integer status location is there, stored location is there. Okay, it is going to return the process ID if everything is okay, else it is going to return the -1. Where wait PID is there, here we are going to take the process ID, stored location, and the int options. So here also it is going to return the process ID if okay, 0 if non-blocking operation, and -1 on the error. So statlock argument can be done in two ways. If statlock is a null pointer, then the argument can be ignored there. If statlock is not a null pointer, then the termination status of the terminated process, okay, the status of your process, terminated process, that status will be stored in the location which is pointed by the argument, and later that status will be accessed by the parent process there. Next is wait 3 and wait 4 functions. These functions are same as wait PID, but it is going to provide some additional information about the resources which has been used by the terminated processes. Here the resources information includes information such as the amount of the user CPU time, the amount of the system CPU time, number of page faults and the number of signal received. These all information will be given to the parent process here. Okay. The syntax will be wait 3 and the wait 4 is there. Here stored location, int option, structure, resource usage, the pointer to that structure. Wait for PID, integer state location, int options. Here also same thing, the pointer to the structure, R usage will be there. That is the resource usage. Next is race condition. Race condition, it is going to occur when multiple processes are trying to do something with the shared data and the final outcome depends on the order in which the process are going to run. Okay, so here race condition means just assume that there is a one printer which is shared by the three processes P1, P2 and the P3. Okay, here P1 have the some data like hello. Okay, then P2 have the data how and P3 will be have the data as you. Okay, all three want to print these three words there. Okay, now as normal what will be the statement, hello, how are you? Okay, so here only one printer is there, okay, which is shared among these three processes. Okay, so the final outcome should be hello, how are you? If while accessing, if anything will be happen, we are going to get the output like how, hello, you, or you, hello, how. So the output of the any operations, okay, the output will be depends upon how the processes are going to access the shared data or the shared resources. That is called as the race conditions. Okay, another one example just I am going to take. Here I have the value as x is equal to 5. Okay, I have the two processes p1 and the p2. Okay, p1 is adding the one value to the x, where the p2 is adding the one it is uh, deleting the 1 from the value x. Okay, so if it will be not done properly, then the value which has been stored in the x is incorrect. Okay, so such condition is called as the race condition. In general, we cannot predict which process runs first. It is totally depend upon the scheduler there. If a process wants to wait for a child to terminate, it must call one of the wait functions there. The problem is that it is going to waste the CPU time. To avoid the race condition, a signals to be used or the interprocess communication can be used there. Then next is exec functions. Exec, it is going to replace the calling processes by a new program. Okay, so whatever the calling function is there, that will be replaced by a new function. A new program has the same process ID as the calling process there. A new program is executed. Exec just replace the current process by the new program. exec is used when the user wants to launch a new file or a program in the same process. These are the some of the form of your exec functions. You will see just here I have displayed that process ID of the example.c. So get PID. I have created one array, character array, hello C programming and the null. Then I have called the execv. Then I have called the one function that is dot slash hello. Okay, and the argument for that will be the args. Okay, whenever this line will be encountered, this execv, then replaced by the new process where it is going to have the same process ID as the example.c. Okay, see here the control will be passed here. We are in the hello.c, then PID of the hello. If you are going to see the output here, the PID process ID of hello.c and the process ID of example.c both will be same here. Okay, thank you.